Hello and welcome to Mathematics with Simon. I'm Simon. We recently posted a video on the proof of the compound angle formulae, and Andy Robertshaw has been in touch with some alternative proofs, which are very interesting. So just let's recap the definitions of the compound angle formulae. Here they are. So Andy's concept is this: you start with a triangle, PQR, and it's made up of two triangles, PQS and PSR. And you start with the formula for the area of that triangle. So the area is a half PQ times PR times the sine of the included angle, A plus B. That is a standard formula for the area of a triangle. And then we also think about the area of the two other triangles. So PQS is a half PQ times PS times sine A. And PSR is a half PS times PR times sine B. Also, we observe that PS equals PQ cos A. PS also equals PR times cos B. So the area of the big triangle is the sum of the areas of the two smaller triangles, and then we substitute for PS. So in the first case, we substitute for PS as PR cos B. And in the second case, we substitute for PS as PQ cos A. And then what we do is cancel the PQ up times PRs, we don't need those, and we just get sine A plus B equals sine A cos B plus cos A sine B. So what's interesting here is that the diagram is simpler, and actually the proof is simpler than the one we presented in the other video. This proof relies on the formula for the area of the triangle, and the other proof had fewer assumptions. So I think that's the trade-off. And we would just have to satisfy ourselves that this formula for the area of a triangle doesn't require the compound angle formula. I don't think that's very difficult to... we could probably prove that quite quickly, actually. I don't think that's very difficult to establish. But that's essentially the point. In general is these proofs, they have slightly more premises. So if we just look at the next one, cos A plus B equals cos A cos B minus sine A sine B. So here we're using the cosine formula. So the point is that QR squared equals PQ squared plus PR squared minus 2PQ PR cos A plus B. That's the kind of standard formula. And then we note that QR is QS plus SR. So we just substitute that and then square that up. QS squared plus 2QS SR plus SR squared. And then, and actually Andy pointed this out in a message to me, it's a really good point. So we're going to subtract QS from both sides and SR from both sides. And we note by Pythagoras that PQ squared minus QS squared is 1. So PQ squared minus QS squared is 1 squared, which is just 1. PR squared minus SR squared is also PR squared minus SR squared is also 1. So you do that substitution, you cancel the 2's. And then we divide through by PQPR. So cos A plus B equals 1 over PQPR minus QS over PQ times SR over PR. And that's all lovely because 1 over PQ is cos A, 1 over PR is cos B, QS over PQ, QS over PQ is sine A, and SR over PR is sine B. So that's the proof again, and again that's a really nice succinct proof, but of course it requires the cosine formula or the cosine rule, which is A squared equals B squared plus C squared minus 2BC cos A is the kind of original form of it. And so again, we'd have to show that the compound angle formula were not required to establish that. We'd have to exhibit a proof of that did not include the compound angle formula, because essentially maths is a foundational discipline where we start with simple truths and build up to more complex truths through the method of proof. And exactly what the foundations are is a very complicated question that we will not be covering in this video, but it's a fascinating question and something I've spent large parts of my life thinking about. It's a very interesting question. And indeed, does mathematics need foundations? Well, if it's a foundational subject, maybe it does. So that's, very interesting. So another around his observations, and I did have this in the original video, but then I took it out, is that sine x is an odd function and cos x is an even function. So an odd function is one for which sine minus x equals minus sine x. And an even function is one for which cos minus x just equals cos x. So cos of minus 30 equals cos 30. Sine of minus 30 equals minus the sine of 30. Tan is also an odd function because actually it's an odd function divided by an even function, which is always going to be an odd function. Not hard to prove. So basically what we do is we start with, this is to prove the formula for sine A minus B. We start with sine A plus B. We substitute in minus b for b. And so what that means is you end up with cos minus b here and sine minus b there. And of course, in the cos term, the minus sign just disappears. And in the sine term, it gets passed through. So you get sine A minus b equals sine A cos b minus cos A sine b. And then looking at cos A plus b, again, we put in minus b for b. And we get cos A cos minus b plus sine A sine minus b, which is cos A cos B, and this should be minus, and you're going to see me changing it in real time. Look at that. The minus passes through. That's the whole point. And look, the way I've done the PowerPoint, we can have a little PowerPoint lesson too, is it's going to pass through. And the next thing is we're going to do tan A minus B. So I'm correcting it on every slide here. Tan A minus B. So again, we put in minus b for plus b, and the minus sign gets passed through on the top, and it gets passed through on the bottom, so it cancels out. So you get 1 minus tan A tan minus b, which becomes 1 plus tan A tan b. And that's how that one works. So those are different proofs, and it's always nice to have different proofs because it just helps you to understand the theorem better. If you can prove it in different ways, helps you understand what it depends on. Just generally exercises those mathematical muscles. So I hope you like the video. I like making it. Please do subscribe and hit the bell. I'd love to hear your ideas, and most of all, I hope you enjoy your mathematics. It's 12:20 here. It's raining outside. I hope you had a nice Saturday night. I just watched One Day on Netflix, which was absolutely fantastic. I hope you're all well. See you soon.